So here's an interesting question. Is the Laplace transform of the derivative of y related to the Laplace transform of y? And gee, it'd be really a waste of time for you to watch this video if the answer was no. So I guess the answer is yes, but the big question is how? So here's what we do. I'm going to take the Laplace transform of y prime and I'm going to write it in its integral form. So that's integral 0 to infinity y prime times e to the negative st dt. And I'm going to use integration by parts to try to get y involved in the game. So I'm going to say that u is equal to e to the negative st and dv is equal to y prime dt. So that means that du is negative se to the negative st dt and v is equal to y. So this is kind of an interesting road to take. So let's see where it leads us. So integration by parts says the integral of u dv is uv. So we have ye to the negative st, and that's evaluated at infinity and 0. So it's going to write it that way for the moment. And then minus the integral of, well, it's y times negative se to the negative st. So that minus and negative is going to become a positive. And we have sy e to the negative st dt, and that's from 0 to infinity. Well, this is interesting because let's just take it piece by piece. So this first one, we have the limit as t approaches infinity of ye to the negative st minus, now if we substitute 0, now y is a function, so we have y at 0, and then we have e to the 0, so there's that. Now this integral, well, let's look at that. It's an integral of something times e to the negative st, but keep in mind the s is constant, so it's really s times the Laplace transform of y of t. So there's our question answered. It is related to the Laplace transform of y of t. But it gets even better than this. So this term right here, well, remember, for the function to have a Laplace transform, that limit has to be 0. Otherwise, the improper integral is going to diverge. So this limit is equal to 0. So we have s times Laplace transform y of t minus y of 0. Now, we sometimes write this as s times y of s minus little y of 0. So from little y, original function, big Y of s, the transform of the function. So this is the Laplace transform of y prime. Now, this can be used to find Laplace transforms of any order derivative that you want to. So let's say we want the Laplace transform of y double prime. Well, by this relationship right here, we know that that is s times the Laplace transform of y prime minus the original function at 0. That's what this has told us right here. It's y at 0 and Laplace of y. Okay? Now, we already know what the Laplace transform of y prime is. I'm going to go ahead and substitute that. So this is s times y of s, the Laplace transform of y, minus y of 0, minus y prime at 0, and I'm going to multiply that out because there's a nice little pattern happening here. And this is the Laplace transform of y double prime. So we now have expressions for the Laplace transform of derivatives of y. Gee, I wonder why we would ever want to do that. Maybe we can apply Laplace transforms to a differential equation. Who knew that this could happen? So when we resume with more videos, we're going to actually be able to solve differential equations using Laplace transforms. Isn't that going to be fun? Let's find out. Thanks for watching.